So student, in the last video I have explained about the charge and the properties of charge. So I am here for you with a new topic, that is Coulombs law. In Coulombs law we have to find the electric force. As you can view on your screen, the heading is electric force. So electric force is basically calculated by Coulombs by his experiment. On the behalf of his experiment, Coulomb says that the force between two charges is directly proportional to the magnitude of two charges and inversely proportional to the square of distance between them. So, as you can see in the figure, let's suppose we have two charges Q1 and Q2. This is charge Q1 and this is charge Q2. Now, if we find the product of Q1 and Q2, so Q1 into Q2, this will be the product. Now, if we increase the product of Q1 and Q2, then the electric force also increases. This is the first experimental result according to Coulomb. Now, if we further the second analysis, then we find that if we increase the distance between the charges, then the square of the distance also increases, and if the distance square increases, then the force decreases. These two basically we can say result which Coulomb carried out. So on the behalf of observations, on the behalf of experiment, he gave a law that is formally known as Coulomb's law and gives us the force between any two point charges. Now, the important term is point charge. So, point charge is that charge which is too small according to its surrounding. So, Coulomb's law is basically applicable on the point charges. So, here F equal 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is the final expression for Coulomb's law. Now, what about the values? So, 1 upon 4 pi epsilon naught is a constant. It is called electric constant. So, this electric constant has always a fixed value. Epsilon naught expressed in air or vacuum. So, its fixed value in air and vacuum is 9 into 10 to the power 9. So, F equal 1 upon 4 pi epsilon naught Q1 Q2 upon R square can be written as F equal 9 into 10 power 9 Q1 Q2 upon R square. Okay, now if we discuss about the unit, we all know that the SI unit of force is Newton. So here the SI unit of force will also be Newton. There is no change in the unit. My next topic is electric field. Now, what is the electric field? So, as you can see on your screen, that electric field is that region in which any test charge can feel the force of any charge. What does it mean? It means, let's suppose we have a charge Q. You can see in the diagram, this is a charge Q. And we have another charge named as test charge Q naught. Now Q naught is at a place where it will not feel any type of force of attraction or repulsion. But as soon as this test charge comes here, then it feels some force of attraction or repulsion. What it signifies? It signifies that as this test charge moves close to the main charge Q, the intensity of the applied force increases rapidly. So, on the behalf of this experiment, we can say that this is the boundary up to which this charge Q can apply a force on any another test charge. Okay, so we can say that the whole region, whole area up to which any charge can apply force on any test charge is simply treated as the electric field. So, according to observation, we have a mathematical formula that is E equal F upon Q naught. So, here we can say per unit test charge, Q naught is taken as 1. So, per unit test charge, F is the force and E is the electric field. So, we can write the force experienced by per unit test charge is called electric field of any charge. Now, if we consider the diagram, this diagram, if we consider in terms of electric force, then we have like this. You can see this is charge Q, this is charge Q naught at any point P, and the distance between them is R. So, here we can apply the force. So, F equal 1 upon 4 pi epsilon naught capital Q, Q naught upon R square. Now, if we place the value of force in the experimental formula E equal F upon Q naught, then simply we get the final result as E equal 1 upon 4 pi epsilon naught Q upon R square. So, I hope these two basic terms, basic formulas, basic definitions, basic concepts you can understand easily. Okay. So, what about the logic to study the electric field? So, logic is simple. What is the logic? Logic is this: if any charge is at rest position, then it simply emits some electric field. How? So, we have two more important points. First point, you can see the electric field of a positive charge is radially outward, and another point is the electric field of a negative charge is radially inward. Here the word radially intensify that the direction of electric field must be perpendicular with the surface. This is the meaning of radially outward or inward. So, now we comes upon our next topic, and the next topic is principle of superposition. What this topic tells about? Principle of superposition. We all know that the principle of superposition is applicable on the vector quantities, and electric field, electric force, both are vector quantities. It means principle of superposition can easily applicable on the electric field as well. Now, firstly we discuss about the diagram. Let's see, in the diagram you can see we have many charges like Q1, Q2, Qi and up to Qn, and their position to any fixed point P is R1, R2, Ri and Rn. Now we have to find the electric field at point P. What should we do? We have to find the electric field by any particular charge to any particular point according to the formula. So we have the formula of electric field, E equal 1 upon 4 pi epsilon naught Q upon R square. So you can see if we apply this formula for charge Q1. For charge Q1 we have E1 equal Q1 upon R1 square with 1 upon 4 pi epsilon naught. Simply for charge Q2, E2 equal 1 upon 4 pi epsilon naught Q2 upon R2 square. Similarly, electric field due to charge Q3, and that will be E3 equal 1 upon 4 pi epsilon naught Q3 upon R3 square. This process can be continued up to nth charge, and simply for any nth charge we have En equal 1 upon 4 pi epsilon naught Qn upon Rn square. Now apply principle of superposition. So principle of superposition states that the total electric field at any point, is always equal to the vector sum of all the individual electric fields on that point. So mathematically we can write this as, you can see, E equal summation from I to n 1 upon 4 pi epsilon naught Qi upon Ri square. So this is principle of superposition. Principle of superposition is applicable in each of that case in which we have more than two charges in any symmetry, like in triangle form, like in a cube or a square. So we can simply apply principle of superposition and we can find the electric field. So the main concept is that the electric field is a vector quantity, so it will follow all the rules of vector addition. So I hope you can better understand the Coulombs law, the electric field, as well as principle of superposition. So I hope and I believe this concept is very clear to all of you. Thank you.